Sometimes we get tracks which go out to the electromagnetic calorimeter, so they measure the energy of electrons, positrons, pi mesons, beg your pardon, gamma rays, and then the outer calorimeter which measures the hadrons, the protons, the neutrons, the pi mesons and k mesons, and finally muons all the way. We're particularly looking for this Higgs particle. One of the ways the Higgs particles will break up is to produce 4 muons, 4 tracks that go right the way. Come through, yes. 4 tracks that will go right the way through the detector. That will be an interesting event. That will be one that we want to collect. Another possibility is 4 electrons, 2 positive electrons, 2 negative electrons, and they will be charged, so they'll give a track in the inner detector and a shower in the inner ring there. Another possibility is 2 muons, 2 tracks going straight out, and 2 electrons, 2 showers in there. So if I could have 2 volunteers, you're obviously a volunteer, right? Yes? No. All you have to do, I'll explain exactly what you have to do, don't worry. And perhaps we could have a female volunteer for the other. Would you like to? Oh, you're filming. Female volunteer, right? Touch the screen to start. Okay, and I'm afraid it's telling you what I've just told you. So we're one of the biggest experiments on the planet. We're going to smash particles called protons together. When it says next, you can touch next. We're hoping to find a new particle called the Higgs, which will explain why some particles have mass, but no one has spotted it yet. Press go. 600 million collisions happening every second, 40 million pictures, but more than one collision in each picture. We take a snapshot to see whether Higgs has been produced. Yes, next. To record every collision would be far too much data, as much as everyone on the planet telephoning 20 people at the same time. Now I don't understand that, because if everybody's telephoning, who are these other 20 people they're going to talk to? But anyway, carry on. So you can see the event on the left is much more interesting than the event on the right. Those are the ones we're going to concentrate on. Next. Now, when you're ready, press go, and you'll have 30 seconds. It will show you a sequence of these events, and if it's an interesting one, you just have to touch the screen to record it. You can let the boring ones go by. Go on. But touch it really firmly. Good. Remember, you're particularly looking for 4 muons, particles that go right out, or 4 electrons, or 2 muons and 2 electrons. Good. Okay, so you've got 5. You've got 5. Right. Okay, so that was just the first stage of the trigger. That's cut it down from 600 million collisions to a couple of million collisions a second. But because there's fewer of them now, we've got a little more time with our